Why is understanding off by one errors key to algorithm design? Imagine building a puzzle and missing one piece or adding an extra one by mistake. Small errors like this can cause big problems in your code. That's what off by one errors are all about. They happen when loops run one time too many or too few, messing up how data is processed. These mistakes often come from misunderstandings about where to start or end a range, especially in programming languages that count from 0. For example, if you want to go through an array of 10 items, you might write a loop from 0 to 9, but if you accidentally write from 0 to 10, you'll try to access an element that doesn't exist. This can cause runtime errors or incorrect results. On the other hand, if you stop one step early, you might miss processing the last item. These errors are sneaky because the code might still run without crashing, but it gives wrong answers. That's why understanding how to handle ranges and boundaries precisely is so important. Using half-open intervals, where you include the start but exclude the end, helps avoid confusion. For example, looping from 0 up to but not including the length of the array makes sure you process every element exactly once. Recognizing patterns like the fencepost error, which is counting fence posts wrong, helps you design better algorithms. From a debugging point of view, mastering off by one errors makes it easier to find and fix bugs that hide in loops and index calculations. Techniques like dry running your loops on paper or writing tests that check boundary cases can catch these mistakes early. When you understand these errors well, you can write code that is more reliable and easier to maintain. In the end, knowing how to avoid off by one errors is essential for creating algorithms that process data correctly and efficiently. It's a fundamental skill that saves you time and frustration when debugging and refining your programs.